Hello everyone, this is Pranav Heureka and welcome to this talk on hacking OAuth 2.0 for fun and profit. We can get started right away, but I'd like to take a moment to thank you all for your time and being here today. And also I'd like to thank Bugcrowd for organizing this LevelUp virtual hacking conference. So let's get started. So little bit about myself. I am Pranav Heureka and I am an active bug hunter. I am in top 10 of Facebook white hats. Some of my popular bugs on Facebook, which I am proud of, are deleting any video from Facebook, which allowed me to take down anyone's video. Facebook awarded me an awesome bounty for that. You can check it on my blog. So I actively participate on bug bounty programs managed by Bugcrowd, HackerOne, Synac, and other independent programs like Facebook, Google. So I'm a bug hunter by heart. I'd like to add that I have transitioned from part-time bug bounty to full-time bug bounty. So I have experienced part-time bug bounty as a student where you manage your school plus bug bounty. I also know how it is to do part-time bug bounty with a full-time job. Also, after everything, I have transitioned to full-time bug bounty. So I did all this in past 4 years. So over the time, I have developed some methodologies which I use to find bugs in any companies like Facebook or Snapchat or Slack or Shopify, etc. I have been very consistent doing bug bounties and managing all my other things, all my daily routine. Apart from this, I have a master's degree in cybersecurity. Then I have also worked at NCC Group in their New York City's office. Currently, I am a full-time bug hunter and I run Peritas InfoSec. In this, I manage the training section whose ultimate aim is to help bug hunters. So I also help run Bug Bounty World, which is community of bug hunters. If you are not already there, please join it. So let's move on. So my aim for this talk is bug hunters want to find bugs and then get paid for helping the company secure their products. For this, bug hunters need right techniques to find valid bugs. Today, I am going to walk you through techniques which I use to pen test any third-party OAuth integrations in a website. And you can follow the same techniques and find similar bugs. So let's get started. Today's agenda is I'll first walk you through history of OAuth and we'll learn some basics about it. Then we will explore different attacks on OAuth 2.0 integrations, which will include a technique which is supported by a case study of a real bug which I have found on real targets. So let's jump into it. History of OAuth. First was OpenID, which is an authentication protocol. Users create account by selecting an OpenID identity provider and then use those accounts to sign on to any website which accepts OpenID authentication. So using one OpenID identity provider, users are able to sign in into other websites without needing any credentials, that is username or password. So this is currently used for single sign-on by many large organizations. But main point here is it is specifically designed for authentication. Second was OAuth, which is authorization framework. OAuth provides client secure delegated access to server resources on behalf of a resource owner. So it specifies a process for resource owners to authorize third-party access to their server resources without sharing their credentials. In simple words, OAuth allows third-party applications to get access to resources of the user without any credentials. That is, without any username, password, they're able to access your resources. And it also gives them limited access to information based on scope permissions of the app. So this is used by Google, Facebook, Twitter, etc. And let's take an example of this. When installing any third-party app on Facebook, Facebook asks you what permission would you like to give to the application. For example, email permission or sharing your friends or only public profile permissions. So that is OAuth. Now, there are two versions in OAuth, OAuth 1.0 and OAuth 2.0. Different companies use different versions based on their needs. In this presentation, we are going to laser focus on OAuth 2.0. So recently, in the last year or so, OpenID Connect was introduced, which is built on top of OAuth 2.0, which addresses all security issues of OAuth 2.0 and is believed to be more secure. So this is a smaller summary of how authentication and authorization evolved over the past. There are also other protocols like SAML, which are used for authentication. But in this talk, we are going to only focus on OAuth 2.0 third-party applications, which are integrated into your websites. So let's move forward. OAuth 2.0 basics. So what is it, how it works, and where it is used? So let's move on. So what is OAuth 2.0? OAuth 2.0 is an authorization framework. It enables a third-party application to obtain limited access to a service or resource. For example, we have login with Facebook buttons on various websites, which gets an access token of the user from Facebook and uses limited information from Facebook to create an account on the website. Similarly, there are functionalities like importing photos from Facebook, importing photos from Flickr. So these functionality might use OAuth 2.0. So OAuth 2.0 is used by Facebook, Google, and many other companies. So let's see how it works. So if you refer OAuth 2.0 RFC, it will give you all technical details. So basically, there are four methods by which a third-party app can get access to resources owned by the user. First is authorization code, where a third-party application gets an authorization code, which is later exchanged for an access token. Access tokens can be used to access resources owned by the user. Second is implicit grant, where a third-party app directly gets an access token. Then the access token can be used to access resources owned by the user. Here, it gets an access token directly. Third is resource owner password credentials. So as the name suggests, a third-party application directly derives an access token by using credentials, that is username and password. Now, fourth is client credential, where application requests an access token to access their own resources. It doesn't work on behalf of the user. It is just accessing its own resources. So here we are mostly interested in attacking first two methods used by third-party applications to derive access tokens for the user. We are going to explore how authorization code grant and implicit grant works and how we can attack it. So let's move on. This is a graphical representation of how authorization code works. I'll be using Facebook everywhere, but you can replace Facebook with any other company like Google, Microsoft, or any other program which has implemented OAuth 2.0. So see this diagram. Here there are four entities. First is application client, which is a third-party app built on Facebook. Second is user, who is resource owner. Third is authorization server, which is Graph API for Facebook. Fourth is the browser. So simple workflow is third-party application will request access to user's resources. Once user grants access to the application, the application will get an access token, which can be used to act on behalf of the user. So let's see how authorization code grant works. First, user authorization request is sent from third-party application to authorization server of Facebook via browser. Second, user have option to authorize the app or install the app on the account. Third is once user authorizes the app, and authorization code will be sent to third-party application via the browser. Fourth, third-party application needs to get an access token, so it sends a request to get an access token. Fifth is if everything is correct, then access token is sent to the third-party application, which can be used to access resources of the user. So here we use authorization code grant because it offers few security benefits. We'll explore on this later. Now let's take an example of this type of implementation. Okay, so this is zoom.us. So Zoom is an application which is used for hosting meetings online or webinars. So this is login page of Zoom, where you can see that user can log in via Google or log in via Facebook. Few things to note that Zoom also has a third-party app built on Facebook, which is used to allow users to log in into Facebook, log in into Zoom with Facebook. So when the user hits sign in with Facebook, user will be taken to authorization page. So this is authorization page on Facebook. This is the first request sent from a third-party application to authorization server, where user can decide whether to authorize this app or not. Here, before going forward, I'd like to highlight certain parameters used in the authorization link. In the top, you can see Facebook's authorization link. First highlighted parameter is response type, whose value is code, which tells that the app is requesting authorization code. Second is client ID, which is unique identifier used by Facebook for identifying apps. Third is scope, which is used to define what permissions are requested by the application. So in this case, Zoom app is requesting public profile, email, and friend list of the user. You can also see the same on the screen. It also tells you. Now, fourth highlighted parameter is redirect URI. This is URL where authorization code needs to be sent after user authorizes the app. Generally, this redirect URI is registered by app developers when apps are created. So now let's authorize the app. After user authorizes the app, the Facebook, who is authorization server, sends an authorization code to the third-party app. So this is where authorization code of the user is sent after user authorized the Zoom application. Now, after receiving authorization code from Facebook, Zoom needs to get an access token. The last step was third-party application uses authorization code of the user and exchanges it with an access token. Here, third-party application sends client ID and authorization code and redirect URI in the request to get an access token. Please note that here, the redirect URI needs to be same as the one which was used to derive authorization code. Otherwise, access token will not be granted to the application. This is additional security benefit of using authorization code grant. In case authorization codes are stolen, it cannot be exchanged with an access token. So this is an additional security benefit of this. Now let's see how implicit grant works. So again, this is graphical representation of how implicit grant works. Here there are four entities. First is application client, which is third-party app built on Facebook. Second is user, who is resource owner. Third is authorization server, which is Graph API for Facebook. And fourth is browser. Now, simple workflow for this is third-party app will request access to users' resources. Once user grants access to the application will get an access token, which can be used to act on behalf of the user. Let's see how how implicit grant works. First, user authorization request is sent from third-party app to authorization server of Facebook via browser. Second, user have option to authorize the app or install the app on the account. Third is once user authorizes the app, an access token will be directly sent to the third-party app via browser. So here, access token is directly granted to the third-party application. We have eliminated the step to fetch an authorization code. Now let's see example of this implementation. So this is Pinterest login page. Here you can see that user can log in via Google or via Facebook. Now, few things we must note here that Pinterest also has a third-party app built on Facebook, which is used to allow users to log in into Pinterest using Facebook. So when user hits sign in with Facebook, user will be taken to authorization page. So this is the authorization page on Facebook. This is the first request sent from a third-party app to authorization server, where user can decide whether to authorize this app or not. Here, before going forward, I'd like to highlight certain parameters used in the authorization link. This link is very much lengthy and contains too many parameters, as Pinterest is using Facebook's SDKs. So in the top, you can see Facebook's authorization link. First highlighted parameter is client ID, which is unique identifier used by Facebook for identifying applications. Second highlighted parameter is redirect URI. This is URL where access token needs to be sent after user authorizes the app. Here, this is Facebook SDK's URL. Third highlighted parameter is response type, whose value is token, which tells that the application is requesting access token. Now, fourth one is scope, which is used to define what permissions are requested by the application. So in this case, Pinterest app is requesting public profile, email, friend list, likes, etc. of the user. You can also see the same on the screen. Now let's authorize this app. Before going forward, let me simplify the authorization URL. This is simplified version of the authorization URL for Facebook. Here I changed response type parameter to token, which tells Facebook that I need access token for the user instead of authorization code. So let's move forward. Now the last step was that third-party app uses access token of the user received from Facebook to log in into Pinterest. So this is the login request of Pinterest, which shows that Facebook access token is directly used in the request. So this is how implicit grant works. Now let's see where OAuth 2.0 is used. You can see that OAuth 2.0 apps are used to import content from websites, like importing photos from Flickr or importing photos from Facebook or contacts from Gmail, etc. Many sites use such applications like Facebook or Google for login by providing login with Facebook or login with Google button. And many sites uses like Uber uses OAuth 2.0 applications for single sign-on. Many other sites do the same for single sign-on. So we are going to focus on applications which are used for logging in and explore different types of attacks on those. So let's move on. Attacks on OAuth 2.0 integrations. So when you are testing third-party applications on websites, then you must consider this three attacks. First is token or code stealing, where we steal access token or authorization codes and use it for compromising user's account. Second is CSRF, where attacker does a CSRF to connect his or her own account to victim's account and then log in via it. Third is token impersonation, which results in authentication bypass. So let's explore. Now, let's explore token stealing, what we do, the secret methodology, and a solid case study of a real bug. So in token stealing, what we do is our main goal is to find third-party app integrations in the website and then steal access token of those integrations. Then take control of user's account using the access token. So first, steal the access token. Second, use it to log in. Here we are specifically focused on third-party login apps. For example, here's a Facebook authorization link where we are directly requesting response type is equal to token, which will give us a token or access token. Let's walk through secret methodology and baby step, which one needs to follow to find such token stealing bugs easily. Okay, so secret methodology. First, find the domain used in the redirect URI. Second, find out if you can use any subdomains in the redirect URI. Third, as we want to steal the token, we want to point the redirect URI to a page where we have an 302 open redirector, which allows to carry forward hash fragments. Or we have an XSS page where we can forward the access token. Or we can just hijack the subdomain and host our own code and steal the token. Or we can try to backtrack the redirect URI to a page which has an open redirector or an XSS. The fourth step is once you steal the access token, then use it for login. These are the normal steps which one needs to follow to steal tokens. Also, I'd like to tell you that you can have different variations in step 3. These are just few limited ideas on stealing the token. I prefer going step by step and taking notes about the behavior. So let's move on and see a case study of this type of bug. Okay, so I found a bug on Snap Publisher, which allowed me to steal single sign-on login tokens of any user. It was found by me on Snapchat. So little bit background information about Snapchat. Snapchat has different products like Snap Publisher, Ads Manager, Business Manager, etc. They are hosted on subdomains like snappublisher.snapchat.com, adsmanager.ads.snapchat.com, such as when you log in on any subdomain, it fetches a single sign-on login token from main application, which is hosted on accounts.snapchat.com. For example, if you want to log in into snappublisher.snapchat.com, then it will ask you to log in into accounts.snapchat.com and then fetch a SSO login token from accounts.snapchat.com. Now, I noticed that this login functionality worked similar to OAuth 2.0. So I can apply my secret methodology and try to steal access tokens of the user. So this is the URL which fetched an SSO login token from accounts.snapchat.com and passed to Snapchat publisher.snapchat.com. Then second request was made to snappublisher.snapchat.com/sso continue question mark ticket is equal to your SSO login token. Now let's apply secret methodology on this URL. First step says that find domain using the redirect URI. Before that, I observed that the referer parameter in the URL can be mapped to redirect URI in our OAuth 2.0. So first step, we identify the domain. So here domain was domain in the redirect URI, or referer was snappublisher.snapchat.com. Second step says that check if subdomains are allowed or not. So here it was allowing only snappublisher.snapchat.com in referer. So we cannot use any other subdomains. Now let's move on with our methodology. Third step was to point the redirect URI to a page where you can steal the token. So luckily I found an XSS by uploading a SVG file, but it executed on storage.googleapis.com, which is not snappublisher.snapchat.com. So this XSS cannot be used to steal the token because we cannot pass this token, because we cannot pass the SSO login token, which is sent in a parameter as question mark ticket is equal to something, as parameters are not getting carried away by 3.0 through redirects from one domain to another. So after finding out this is my reaction, because I'm stuck at step 3 of my secret methodology. Now let's move on. Now I found out that the image link, where I uploaded a SVG file, which got me accesses on storage.googleapis.com. So the image link like snappublisher.snapchat.com/API/version1/media, some media/file something.svg redirected to storage.googleapis.com. So I can use hash fragments and send data in hash fragments from snappublisher.snapchat.com to storage.googleapis.com. And this, I can send the SSO login token to my XSS page, which is on storage.googleapis.com. So bypass was using an hash fragment and carrying SSO login token forward to my XSS page. So after that, I was happy until I found out that it's a self XSS. So it can be, the XSS page can be consumed to steal tokens only for myself or any other admin who has similar permissions like me. It cannot be used against any other user. So this is my reaction, because I was pretty close to exploit this bug for any user, but I got stuck because it's a self XSS. I can steal the token, but it's a self XSS and I can steal only my tokens. So I researched more. Later, I found out that I can do CSRF login on snappublisher.snapchat.com and log any user into my own account. So this is my reaction, because now I can just steal any other user's SSO login token and take control of their Snap Publisher account. And also using that token, I can just access everything, all the APIs for that Snap Publisher account. Also, there was an admin panel behind, which is used by Snapchat employees, so whose APIs can be accessed by me. So if I am able to steal token of an employee, then I get access to the internal admin panel as well. So Let me simplify the attack flow for you. So attack flow is first victim logs in into main application, which is accounts.snapchat.com. Second, attacker CSRF logins victim into his own account on snappublisher.snapchat.com. Third, attacker sends the token stealer link, which steals victim's SSO login token received from accounts.snapchat.com, the main application, by forwarding it to from one domain to another, and finally taking that the SSO login token to my self XSS page. So this is how the attack flow look like. Now let's move on. So these are the actual POC. This is the CSRF login link, which logs the victim into attacker's Snap Publisher's account. At this time, victim is already logged in into his own account on main application, which is accounts.snapchat.com. And then victim is logged in into attacker's Snap Publisher's account. Second, send the token stealer link. This link will fetch a SSO login token from main application, which is accounts.snapchat.com of the victim, and pass it on to the XSS page. And XSS page inside is inside attacker's account, attacker's Snap Publisher account. Thus, attacker gets control of the SSO login token of victim, which can be used to log in and access all the APIs. Thus, whole account of the victim is compromised. So, bounty awarded for this bug was $7,500. Few bugs in this chain were duplicate. That's why they rewarded only 7,500. Now let's move on to next section, which is code stealing. Let's explore this. In code stealing, what we do is our main goal is to find third-party integrations in the website and then steal authorization codes of these integrations. Then take control of user's account using authorization code. So first step is steal the authorization code. Second step is use it to login. Here we are specifically targeting third-party login apps. For example, here's a Facebook authorization link where we are directly requesting response type is equal to code, which will give us authorization code. Later, this authorization code will be exchanged with access token by the application. Now, in code stealing, there's one exception. Redirect URI while exchanging the authorization code with access token must match when we got authorization code. Thus, your request for exchanging an authorization code with an access token will fail if redirect URI in both requests doesn't match. Let's walk through secret methodology and baby steps which one needs to follow to find such code stealing bugs easily. So the secret methodology. First, find the domain used in redirect URI. Second, find out if you can use any subdomains in the redirect URI. Third, check if authorization code derived from manipulated redirect URI works when fetching access token. This is because you don't want to waste your time if the application is not able to process the authorization codes with manipulated redirect URIs. Fourth, as we want to steal the code, we want to point the redirect URI to a page where we have an XSS where we can forward the authorization code. Or we can just hijack any subdomain and steal the code. Or find a page where we can load user control images or scripts where we can leak the URL in referrer header. So fifth is once you steal the authorization code, then use it for login. Also, I'd like to mention you can try finding an open redirect where you don't mess with redirect URI. So your stolen authorization code will work in that case. These are normal steps which I follow to find such kind of bugs. Also, you can try different variations in step 4 where you steal the authorization code. These are some limited ideas. So let's move on and let's see a case study of this type of bug. So I found a bug which allowed me to steal login authorization codes of users, and it was found by me on a private program, so I cannot disclose name of the program. Little background information about the website. Company allowed registering subdomain of your choice in a paid plan. On the subdomain, one can customize HTML or load images or do whatever he wants. The site was using login with Facebook functionality, and it was using authorization code for login. So Facebook's authorization codes were used for login. So now I can apply my secret methodology and try to steal the authorization codes of the user. So this is the URL which fetched an authorization code from Facebook and logged the user in. Let's apply our secret methodology. First step says that find domain using redirect URI and privatesite.com was used. Second step says that check if subdomains are allowed or not. And here it was allowing all subdomains in the redirect URI. Now let's move on. Now step third in the secret methodology says that check if authorization code derived from manipulated redirect URI works when fetching access token. So Facebook's manipulated redirect URI's authorization code won't work. So challenge here is we need to steal authorization code without manipulating redirect URI of the Facebook app. Now, later I observed that state parameter in the authorization URL can be used to redirect to any internal subdomain. So let's move on. So according to step 4, we need to redirect the authorization code to a page where we can have XSS or have something like loading external images or something which can be used to leak the authorization code or parameters via referrer header. So for this, I bought a paid plan and I got the subdomain and I hosted my own images from my own website. So I can use this chaining of attack and steal anyone's authorization code and then use it for login. So this is my reaction at that time because I was able to just steal anyone's authorization code and take over the whole account. So let's walk through attack workflow, how the attack worked. First, victim is logged in into privatesite.com via Facebook login. Second, attacker logs out the victim via logout CSRF. Third, send victim Facebook POC link. Fourth, this link sent authorization code to subdomain, which was under attacker's control, which was bought by attacker in a paid plan. Fifth, subdomain leaked the URL to images loaded from attacker's website via referrer header. Sixth, attacker can then use the stolen authorization code to log in into victim's account. Thus, whole account of victim got compromised. Now, this is the final POC link. Here, note the state parameter which I manipulated to redirect to my subdomain, which I purchased in a paid plan. Here, I also backtracked the in the state parameter to just point to the home page of my site. So finally, it was sending the authorization code to subdomain.privatesite.com/code is equal to authorization code. So I could use this authorization code to log in into victim's account. So bounty awarded for this bug was $1,000. This was the maximum bounty awarded by the program. Now let's move on to next section, CSRF. Let's explore CSRF bug now, what we do, the secret methodology, and a case study. In CSRF, what we do is our main goal is to connect attacker's Facebook account to user's account, then log in via attacker's Facebook account into user's account. Here, you can replace Facebook with any third-party integration of your choice. Now, look at the Facebook authorization link. In this link, there's a state param, which is NTCSRF parameter. If the state param's value is guessable or state parameter is not used or its value is not validated, then the integration is vulnerable to CSRF. Let's walk through secret methodology and baby step to find such CSRF bugs easily. So the secret methodology. First, check if state parameter in OAuth authorization link is validated. Second, derive yourself a valid authorization code link and do not use it. Third, send this active authorization code link to the victim. Fourth, your account will get connected with victim's account. Now you can log in via Facebook, via your own account into victim's account. These are normal steps which one needs to follow to CSRF connect your Facebook account to victim's account. So let's move on and see a case study of this type of bug. So I found a bug which allowed connecting attacker's account to victim's account due to missing validation of state parameter in Facebook app. It was found by me on a private program, so I cannot discuss private details about the company. So a little bit background information about the company. Company allowed connecting your Facebook account with the application. Now, any content saved in the application will get auto shared to Facebook. I observed that the state parameter in the OAuth link never got validated. So now I can apply my secret methodology and try to connect my Facebook account to victim's account. So this is the attack workflow. First, attacker initiates connect with Facebook flow. Second, attacker derives a valid authorization code link and doesn't use it. Third, victim is logged in into privatesite.com. Fourth, attacker sends active authorization code link to the victim. Fifth, attacker's Facebook account is now connected to victim's account. Sixth, any content saved or posted in victim's account will get shared to attacker's Facebook account. Thus, attacker got access to the private content of victim. Now let's explore the POC. This is the final POC. First, attacker gets an authorization code and he doesn't use it. You can see these two links, and in the second link there's an authorization code. Do not go forward with this request, you just save it. Now send this link to victim. Attacker sends this link to the victim. So now attacker's Facebook account will get connected to victim's account, and thus indirectly anything posted on victim's account will get shared on attacker's account, attacker's Facebook account. Thus attackers getting access to private content of the victim. Now bounty for this bug was nothing because someone already reported this bug. Now let's move on to next section. Token impersonation, what we do, the secret methodology, and a case study to support this. In token impersonation, our main goal is to find third-party integrations in the website and then get victims valid access token from a different app and pass the access token to login endpoint and bypass authentication. So first, get a valid access token. Second, pass access token of the victim of different app to the login endpoint and get unauthorized access to the account. Let's walk through secret methodology to find such bugs easily. First, check if login endpoint accepts access token directly. Second, derive an access token from a different app. Third, pass it on to the login endpoint. If you are able to log in use an access token from a different app, then it's a authentication bypass bug. These are normal steps which needs to be followed to find such type of bugs. Let's take a case study about this. I found the authentication bypass bug by using any valid access token to log in into the app. This was found on a private program, so I cannot share details about the company. Little background information about the app. Company used login with Facebook account functionality, and they were using access tokens to directly log in. So applying the secret methodology, first step says to check if login endpoint is using access tokens to log in. And yes, it was using Facebook access tokens. Now I can just apply my secret methodology and try second and third step. So attack workflow. First, attacker derives an access token for the user from a different app. Second, attacker uses it to bypass authentication. Let's see the POC. Here, this is the request made by the application which used Facebook's access token to log in. So it was possible to use any access token of the same user from a different Facebook app and then bypass login. So it would log in into the user's account directly. Now, bounty awarded for this bug was $1,000, and this was the maximum bounty awarded by the program. But the bug was critical for them as it allowed to bypass authentication. Now, let's go to conclusion. These are 3 secret techniques to use when pen testing any third-party integrations on a website. First is token code stealing, where we try to steal access tokens or authorization codes and use it for login. Second is CSRF, where we try to connect attacker's account to victim's account and then take over victim's account via login in into via attacker's account. Third is token impersonation, where we try to bypass authentication by using access tokens generating from different apps. Now, a message for bug hunters. To earn more, you must learn more. So invest time in learning more. I apply this in my daily life, and you should also apply this and learn newer concepts so that you can do good and help the world be secure. Now, thanks. I'd like to first of all thank Bug Crowd team for hosting this conference. Secondly, I'd like to thank the audience and everyone who is listening to me for so long. And you can check out my trainings on training.paritosinfosec.com. Also, if you have any questions, I'll follow up with you on Bug Crowd forums. So that's it. Thanks.